Good day. I hope you are safe and you are doing well. Alright, in our previous class, we considered specific heat capacity. Today, we shall be proceeding with latent heat. But before we go on with this, I want you to remember that when you apply heat to a body, it doesn't only cause a change in temperature, it also causes a change in state. As we see in water, when heat is being applied to ice, it causes the ice to transform from being solid to liquid. And when you further apply heat, what happens? It changes to vapor. Also, we have to be familiar with the terms associated with this change of state. When a solid changes to liquid, we call it melting or fusion. And when the liquid changes to gas by application of heat, we call it vaporization or evaporation, depending on the temperature this happens. Also remember that the reverse can occur. That is, this vapor can turn back to liquid, which we call condensation. And when liquid turns back to solid, we call it freezing. To understand this latent heat very well, let's create this picture. We understand so well that water boils at 100 degrees Celsius, after which it vaporizes. But then, we know that when water boils, we still apply heat till the water vaporizes. Yet, temperature doesn't change. It remains at 100 degrees Celsius. What I'm trying to say is this. When you boil your water, from the time the water is boiling till the time it evaporates, the temperature doesn't change, even when heat is being applied. So the question is, what happens to the heat being applied to this water? Or where does the heat go to? That is what latent heat explains. Whenever a body or a substance changes its state, that is either from solid state to liquid state or from liquid state to gaseous state, it absorbs heat or it gives off heat which is not being dictated by the thermometer. And this heat is what we know as latent heat. While boiling your water, when it was boiling and you were still applying your heat, this water absorbs this heat as latent heat, which vaporizes or which escapes together with the vapor. In essence, this latent heat is a heat being absorbed, heat energy being absorbed or being evolved by a body while it is changing its state. And as the name implies, latent heat is hidden. It is not being dictated by the thermometer. What am I trying to say? It is not being dictated, which means that it doesn't cause any temperature change. The temperature remains the same, yet the body changes its state. It also happens while melting. We know very well that water freezes at 0 degrees Celsius. Also, when it melts at the same temperature of 0 degrees Celsius. If you understood this picture with me, I think I'll now proceed into defining latent heat. By definition, we can say that latent heat is the heat supplied or removed by a body which causes a change of state without a change in temperature. In essence, this heat causes only a change of state. It doesn't cause a change in temperature. It is either absorbed or released by the body. In my earlier example, when the water was boiling, it was only absorbing this heat as latent heat, which enables it to change its state from liquid to gaseous state. That is just latent heat. It doesn't cause a change, that is a rise or a fall in temperature. The temperature remains constant while the body changes its state. When this latent heat is associated with melting, it is called latent heat of fusion. So what is this latent heat of fusion? Latent heat of fusion is the heat required for a body to change from its solid state to a liquid state without a change in temperature. Again, it is the heat energy needed which enables the body to change from its solid state to its liquid state. That is latent heat of fusion. When it is associated with vaporization, it is known as latent heat of vaporization. So it's very, very easy. Latent heat, the hidden energy which is being absorbed by the substance but is not being dictated by the thermometer. It only causes a change in state without a change in temperature. If we are now on the same level, let us proceed with latent heat of fusion. Remember, it is not dictated. There is no change in temperature. It is only dependent on the nature of the substance and the mass of the substance. So if while dealing with specific heat capacity, we had H to be mc theta, where H is the quantity of heat, m is the mass of the substance, c is the specific heat capacity, and theta is the change in temperature. I hope you still remember that. Then dealing with latent heat of fusion, since we are not considering any temperature change, we shall still go on with the formula, only that you are going to exempt this theta because we are not dealing with any temperature change. And here, instead of C, which represents specific capacity, we are going to deal with L, which represents latent heat of fusion. Thus, our formula will now be M is equal to mL, where M is the mass of the substance, L is the latent heat of fusion, and H is the quantity of heat supplied. From here, we can ask that L is equal to H over M, which is heat over the mass of the substance. We can see that if we want to derive the SI unit of latent heat of fusion from here, it can easily be derived from this formula. Since we have H in joules and then mass in kilogram, therefore the SI unit for latent heat of fusion is joule per kilogram. The first example we have here states how much heat is required to change 2 kilograms of ice at 0 degrees Celsius to water at the same temperature. And we are given the specific latent heat of fusion of ice as 3.36 times 10 raised to power 5 joule per kilogram. From the question, we are asked the amount of heat in joules which be needed to just melt 2 kilogram mass of ice. But they said at the same temperature, that is just melting. Remember, there will be no change in temperature. Having known this, we can now proceed solving this using the formula which states that H is equals to mL. Here we are given our M, which is the mass, and we are given our latent heat of fusion. So to find the amount of heat needed to now be 2 times 3.36 times 10 raised to power minus 10 raised to power 5. If you multiply out, we are left with 6.72 times 10 raised to power 5 joules. Therefore, the amount of heat needed to just melt 2 kilogram mass of ice to water at the same temperature is 6.72 times 10 raised to power 5 joules. The second example we have here states what quantity of heat will be needed to melt 3 kilograms of ice at minus 10 degrees Celsius to water at 15 degrees Celsius. This example is a bit tricky. Firstly, you have to understand the question. Note, the ice was not initially at 0 degrees Celsius. No, rather it was at minus 10 degrees Celsius. Therefore, it means that you have to apply heat so that it will increase from minus 10 degrees Celsius to 0 degrees Celsius. Remember, 0 is greater than minus 10. Therefore, it means that there must be specific heat capacity of ice. That is to increase the temperature from minus 10 degrees Celsius to 0 degrees Celsius. That is the need for specific heat capacity of ice, which is given to us as 2,100 joule per kilogram per Kelvin. Again, when this ice gets to 0 degrees Celsius with the help of the specific heat capacity, then we also need to convert this ice from 0 degrees Celsius to water at the same 0 degrees Celsius. That is simple melting. That is the need for what? Specific latent heat of fusion of ice. That is the one needed to convert the ice, which is now being converted to 0 degrees Celsius, to water at the same temperature of 0 degrees Celsius. The question continues, to water at 15 degrees Celsius. That means we also have to heat up that water converted from 0 degrees Celsius to 15 degrees Celsius. I hope you now see the steps. We have to apply heat to convert it to raise the temperature from minus 10 degrees Celsius to 0 degrees Celsius. Then we need specific latent heat of fusion to convert it from 0 degrees Celsius to water at the same temperature. Remember, no change in temperature. Then we also have to apply heat the more to change it from 0 degrees Celsius to 15 degrees Celsius. That is the need for specific heat capacity of water. You can see they are all interrelated. So if you have understood the logic, can we now proceed with solving the question? We shall proceed with, first and foremost, the heat, because the combination of this heat gives us the total heat required to convert this 3 kg of ice from minus 10 degrees Celsius to water of 15 degrees Celsius. So let's proceed with the one needed to convert the ice from minus 10 degrees Celsius to 0 degrees Celsius. Therefore, we have H equals to mc theta. That is specific capacity. Because we need to raise the temperature. There will be temperature change. We're talking about latent heat this time around. So here, our aim is 3 times specific capacity of ice, 2,100 times temperature change. Remember, 0 minus 10. This is the figure on this, so minus 10. Theta 2 minus theta 1. Which is us 3 times 2,100 times 10, which is 63,000 joules. That's heat 1. Since we found the amount of heat needed to change the temperature from minus 10 degrees Celsius to ice of 0 degrees Celsius as 63,000 joules, we are now left to find the heat again needed to melt the ice from 0 degrees Celsius to water at the same temperature of 0 degrees Celsius. So we're just talking about melting, which is change of state. Thus, we have to use our latent heat of fusion of ice, which is given to us as 3.36 times 10 raised power 5. So the second heat we're interested in now is latent heat of fusion, which is H is equal to ml equal to the mass is given to us as 3 times the latent heat, which is 3.36 times 10 raised power 5. Our answer is 1.008 times 10 raised power 6 joules. Therefore, the amount of heat needed to melt the ice from 0 degrees Celsius to water at the same temperature of 0 degrees Celsius is 1.008 times 10 raised power 6 joules. Alright, we have gotten the amount of heat needed to change the temperature from minus 10 to 0 degrees Celsius. We have also gotten the amount of heat needed to melt the ice, the same mass, from 0 degrees Celsius to water at the same temperature of 0 degrees Celsius. So the next thing is, what amount of heat is needed to raise the temperature of the water from 0 degrees Celsius to 15 degrees Celsius? Remember the question. It states the amount of heat required to change 3 kg mass of ice from minus 10 degrees Celsius to 15 degrees Celsius. We have gotten to this stage, so we proceed. H is equal to mc theta. Theta comes in because we're talking about temperature change. That is from 0 degrees Celsius to 15 degrees Celsius. It's equal to the mass, which is 3, times specific heat capacity of water, we're talking about water now, 4,200, times the temperature change, which is theta 2 minus theta 1. Theta 2 is 15 minus theta 1, 0. So we're left with 3 times 4,200 times 15, which gives us 189,000 joules. Okay, we have found the first heat and 63,000 joules needed to convert from minus 10 degrees Celsius to 0 degrees Celsius. The second heat has 1.008 times 10 to the power 6 joules needed to melt the ice from ice of 0 degrees Celsius to water at the same temperature of 0 degrees Celsius. Then the third heat needed to raise the temperature from 0 degrees Celsius to 15 degrees Celsius is 189,000 joules. And we are asked to find the total amount of heat. It will now be the first heat plus the second heat plus the third heat, which is 63,000 plus 1.008 times 10 raised to the power 6 plus 189,000, and that gives us our final heat as 1.26 times 10 raised to the power 6 joules. So dear friends, the total amount of heat needed to convert this 3 kilogram mass of ice from minus 10 degrees Celsius to water of 15 degrees Celsius is 1.26 times 10 raised to the power 6 joules. What a great amount of heat we need here. I believe you can just take your time, go through the example once more, understand it very well, and then you can go on to explore every other question out there. Alright, in my next video, which I still hope to see you, we shall go into solving for latent heat of fusion using the mixture method, that which involves the calorimeter, and I know most students find this very difficult. So I hope to see you there, where we shall deal with this and make it look so easy. Thank you so much for being with me in this video, and I hope to see you in the next video. But before then, as usual, let's try this evaluation. Okay, I would like you to try this evaluation, as it could help as well to know how much you have understood the topic. What quantity of heat will be needed to change 2 kilograms of ice at 0 degrees Celsius to water at 10 degrees Celsius? Given that the specific heat capacity of water is 4,200 joule per kilogram per Kelvin, and the specific latent heat of fusion of ice is 3.36 times 10 raised to the power 5 joule per kilogram. Please friends, most especially my students, please and please try the evaluation, and don't forget, if you have a question or confusion, please try to type in the comment section, and as well type in your answer. I love you so much. Stay safe.